Hello, and welcome back to Sleepy Universe. Let the day's concerns drift away now. There is nothing to hold on to, nothing to achieve. Simply allow your body to relax and your mind to grow quiet and deep. Tonight, we journey to the most serene and profound mysteries of the cosmos, black holes. We will explore 100 sleepy facts about these silent anchors of space, from their gentle birth in the collapse of stars to their patient evaporation over eons. You don't need to remember any of this. Your only purpose is to listen and to let your awareness be drawn into their deep, quiet embrace. So, settle in. Feel yourself fully supported. With each exhale, release the world. With each inhale, draw in the silent peace of the void. Just listen and imagine we are floating in the perfect, soundless dark near a sleeping black hole, a place where the universe has grown so still and heavy that it has fallen into the deepest of slumbers. Let's begin. A black hole begins its life not with a roar, but with a silent, gravitational sigh, as a truly massive star, having burned through the last of its nuclear fuel, can no longer support its own immense weight. In these final, quiet moments, the star's own gravity, once balanced by the outward push of fusion, turns inexorably inward. The core falls silently into itself, in a patient, catastrophic collapse, condensing into a point of infinite density, while the star's outer layers are often cast gently adrift in a final, luminous supernova, a brilliant, fleeting flower that blooms only to signal a deeper, darker birth. This quiet, profound implosion creates a boundary in space-time from which not even light can return, a gentle but absolute drawing of the cosmic curtains, a silent origin in the peaceful aftermath of a star's long and energetic life. The boundary of a black hole, the event horizon, is not a solid, physical surface, but a perfect, silent sphere of no return, a one-way door out of our visible universe woven from gravity itself. It is a place of perfect peace and finality, a threshold where the escape velocity equals the speed of light, meaning that all possible futures for any object that crosses it point irrevocably inward. From the outside, it appears as a dark, smooth surface, a frozen waterfall of space and time, an ultimate and unbreakable horizon. To cross it is not necessarily to be torn apart, but to have your trajectory through the cosmos so gently and completely bent that every path leads deeper into the interior, a peaceful, final journey into the deep, dark heart of the whole, where the concepts of here and there softly dissolve into a single, silent point. The point of infinite density at the center of a black hole is known as a singularity, a place where the laws of physics as we know them fall into a peaceful, silent slumber, and our understanding of the universe reaches its quiet end here. Matter is crushed into a state beyond our comprehension, a realm where the familiar rules of space and time simply cease to have any meaning, and the very fabric of reality as we perceive it unravels into a pure mathematical idea. It is not a place of violence or chaos, but of ultimate quiet mystery, a profound secret kept by the universe, a final hidden rest for all the mass and energy that has ever crossed the event horizon, gathered into a single, unknowable point. Despite their name, Black holes are not empty holes in space. They are the very opposite. They are perhaps the most densely packed objects in existence, where a mass greater than our Sun is patiently contained within a sphere only a few miles across, a concentration of existence so intense it is almost impossible to picture. They are not voids, but incredible, silent anchors of gravity, sitting in the cosmic dark with a mass so profound it bends the very fabric of reality around itself in a gentle, smooth curve. Imagine the entire history of a mountain, from its tumultuous birth to its slow erosion, compressed into a single, silent grain of sand. A black hole is a cosmic expression of that same patient, immense concentration, a testament to the power of gravity to gather and hold, to simplify the universe into a point of profound. There is a region just outside a black hole's event horizon called the ergosphere, a gentle, swirling corridor of space-time, dragged into motion by the black hole's immense rotation. In this oval-shaped region, nothing can remain at rest. The very space itself is pulled around in a slow, cosmic whirlpool, a current in the fabric of the cosmos. It is a place of gentle, inevitable motion, a final, slow carousel ride before the final descent into the event horizon. Any object entering the ergosphere is forced to move with the spinning space-time, a peaceful testament to the power of a black hole to stir the very void around it, to impart its own slow, stately spin upon the universe immediately surrounding its dark heart. Our own Milky Way galaxy has a silent, sleeping giant at its heart, a supermassive black hole named Sagittarius, a star, containing millions of times the mass of our Sun. For now, it is quiet and faint, a slumbering behemoth that only occasionally stirs to sip on a passing cloud of gas or a wayward star, flaring softly with a whisper of its potential power. Its immense, invisible pull is the silent conductor of the orbital dance of stars at the galactic center, which whirl around this dark anchor at breathtaking speeds. This presence is felt but not seen, a deep and peaceful enigma that sits at the center of our galactic home, a reminder that the heart of our vast, spinning city of stars is a place of profound, dark quiet. The experience of falling into a black hole depends entirely on its size. For a small, stellar mass black hole, the tidal forces, the difference in gravity between your head and your feet, would be overwhelming, stretching you apart in a process called spaghettification. But for a supermassive black hole, with its event horizon located far from the central singularity, the gradient of gravity is incredibly gentle and gradual. You could cross the event horizon peacefully, feeling no sudden jolt, no dramatic tug, just a serene and silent passage into the interior. The universe outside would appear to speed up, its light blue shifting, then red shifting into a final, silent picture as you drifted deeper into the dark, a solitary and peaceful journey to the center of gravity's embrace. Black holes can hum a gentle, cosmic lullaby. When two black holes spiral towards each other in a final, slow dance, they create ripples in the fabric of space-time, known as gravitational waves. These are not sounds that travel through air, but vibrations in reality itself. If we could translate them into sound, the merger would be a gentle chirp that rises in frequency and amplitude before fading into a silent ringdown, like a single, quiet note from a cosmic cello. It is the universe's quietest and most profound melody, a peaceful chord played on the strings of space-time, a signal that even in the most intense gravitational events, there is a rhythm, a pattern, a beautiful and transient music in the dark. Matter falling into a black hole doesn't vanish silently. It often announces its arrival with a gentle, final glow. As gas and dust are drawn in by the immense gravity, they do not fall straight down, but spiral inward, forming a vast, flat structure called an accretion disk. In this slow, majestic whirlpool, particles are compressed and rub against one another, heated by immense friction and gravitational energy to millions of degrees. This causes the disk to glow with a brilliant, soft light across the X-ray and gamma-ray spectrum. From a great distance, this is a peaceful, luminous beacon, the last testament of material peacefully surrendering to the pull of the dark heart, illuminating the black hole's silent presence with a final, energetic sigh. The accretion disk around a black hole is not a uniform sheet of light, but a complex, slow-motion whirlpool with its own intricate structure. The outer edges rotate at a stately, slow pace, while the inner edge, just outside the event horizon, whirls at nearly the speed of light, a silent, frantic dance against the abyss. Within this disk, magnetic fields can twist and snap, launching vast jets of material back out into space, while the rest continues its serene spiral inward. It is a place of both creation and destruction, where matter is heated into a brilliant plasma that paints the black hole's dark silhouette with a soft cosmic fire, a beautiful and temporary contrast against the eternal dark. According to Einstein's theory of general relativity, a black hole is an object of beautiful simplicity, defined by only three properties: its mass, its electric charge, and its spin. This is known poetically as the no-hair theorem, suggesting that black holes are simple, bald, and peaceful objects. All other intricate details about the matter that formed them, whether it was a star made of hydrogen or iron, or a spaceship with complex machinery, are lost, erased behind the event horizon. They are silent, minimalist sculptures in the gallery of the cosmos, their complex pasts forgotten, defined only by the most fundamental, measurable quantities, a peaceful simplification of existence itself. From the perspective of an outside observer, time for an object falling into a black hole appears to slow down, approaching a complete and eternal stop at the very brink of the event horizon. This is a consequence of the extreme gravitational time dilation predicted by Einstein. An astronaut falling in would seem to freeze in place, their image reddening and fading over eons, like a gentle, eternal photograph painted onto the surface of the horizon. It is a peaceful, optical illusion born from the extreme warping of space-time, a final, slow farewell that lasts forever in our frame of reference. While from the astronaut's perspective, their journey continues, serene and uninterrupted, into the heart of the dark. Black holes are not truly eternal. Over timescales so vast, they dwarf the current age of the universe. Trillions upon trillions of years, they slowly evaporate through a subtle quantum process known as Hawking radiation. At the event horizon, virtual particle pairs constantly flicker in and out of existence. Occasionally, one particle falls into the black hole while the other escapes, stealing a tiny amount of energy from the black hole's gravitational field. This causes the black hole to slowly lose mass, emitting a faint thermal glow in a gentle, quiet whisper. Over an almost unimaginable eternity, the black hole will shrink, eventually fading away into a final, silent puff of radiation, a peaceful end to the universe's most enduring anchors. The point of no return for a spaceship hoping to orbit a black hole is not the event horizon, but a much farther boundary called the innermost stable circular orbit. Within this region, space-time is so severely warped by the black hole's gravity that a stable orbit is impossible. The mathematics of relativity show that any object must either use energy to escape or begin its inevitable, gentle spiral inward. It is the true beginning of the final descent, a peaceful, one-way path where the gravitational embrace becomes inescapable. This boundary is the last place where light can still theoretically orbit, a final halo of photons tracing the dark sphere within. The process of spaghettification is a gentle, if extreme, stretching caused by tidal forces. If you fell into a black hole feet first, the gravitational pull on your feet would be significantly stronger than on your head, and the pull on your head stronger than on your waist. This difference in force would gradually and peacefully stretch your body into a long, thin stream of atoms. For a stellar mass black hole, this happens violently and quickly close to the singularity. But for a supermassive black hole, the transition is so gentle and gradual across your body's length that it would be a seamless, almost imperceptible process, a slow and silent elongation as you drifted deeper into the dark, a peaceful unification with the relentless flow of gravity. Black holes can theoretically be connected by tunnels in space-time called wormholes or Einstein-Rosen bridges. These are not traversable passages as in science fiction, but mathematical possibilities that arise from the equations of general relativity. They are like peaceful cosmic shortcuts, a gentle folding of the universe's fabric that connects two distant points, or even two different times. However, these bridges are inherently unstable, predicted to collapse into a singularity in an instant, long before any information or matter could pass through. They remain beautiful, theoretical ghosts, a whisper of the universe's hidden connectivity, a peaceful dream of travel that the laws of physics, in their wisdom, keep just out of reach. A black hole's spin can, in theory, provide a potential source of energy, a concept known as the Penrose process. In the ergosphere, the region of swirling space-time outside the event horizon, the rotation is so intense that an object can enter and fragment, with one piece falling into the black hole while the other is flung out with more energy than the original object had. The black hole itself loses a corresponding amount of rotational energy, slowing its spin slightly. It is a peaceful, almost alchemical transformation, a way of gently mining the rotational energy of a black hole, converting its silent, spinning momentum into usable power for a hypothetical, advanced civilization. The size of a black hole, specifically the radius of its event horizon is directly proportional to its mass. This relationship is beautifully simple. Double the mass, and you double the radius of the horizon. This means supermassive black holes, despite their immense weight, have a very low average density. A black hole with the mass of our Sun has a horizon only about 3 kilometers across, but one with the mass of 1 billion suns has a horizon billions of times larger, and its average density can be less than that of air. This reveals their nature not as infinitely dense points, but as vast, dark regions of space where gravity has gently but absolutely taken command. From the inside of a black hole, the singularity is not a place in space you are moving toward, but a moment in time you are inevitably rushing toward. Once across the event horizon, all future paths through space-time lead to the singularity. In a sense, the roles of space and time switch. Just as in the outside universe you cannot avoid moving forward in time, inside a black hole you cannot avoid moving toward the central point. It is a peaceful, deterministic journey, where the future is singular and assured, a final, quiet destination that awaits every traveler at the end of their inward timeline. The magnetic fields around a black hole are not generated by the hole itself, but by the ionized gas in its swirling accretion disk. This hot, charged plasma, moving at relativistic speeds, can generate and amplify magnetic fields of immense power. These fields can twist into towering structures, acting as conduits that channel some of the infalling material into powerful, focused jets that shoot out from the poles of the black hole at nearly the speed of light. These jets, visible across the universe, are a silent, brilliant testament to the complex and dynamic processes that occur in the peaceful, dark space just outside the point of no return. There exists a perfect, ethereal sphere of trapped light just beyond the event horizon, a region known as the photon sphere, where gravity bends the fabric of space-time so profoundly that photons are forced to travel in unstable, circular orbits. Here, light itself becomes a prisoner, tracing silent, luminous halos around the ultimate dark. A photon entering this sphere might loop around the black hole once, twice, or an infinite number of times, like a slow celestial marble rolling on the very rim of a bottomless cup, before its precarious path is disturbed, and it either escapes to carry a warped image to a distant observer, or finally surrenders, spiraling gently inward to be swallowed by the silence below. It is a final, beautiful, and transient ballet of pure energy at the very edge of oblivion. The theoretical concept of a white hole presents a serene and symmetrical counterpart to the black hole, a hypothetical region of space-time where nothing can ever enter, but from which matter and energy eternally and peacefully flow outward. Imagine a cosmic spring, an everlasting fountain of creation, perpetually pouring light and substance into the universe. While almost certainly not a physical reality we can observe, the white hole exists as a beautiful mathematical echo within Einstein's equations of general relativity, a gentle speculative whisper of a universe that might possess a perpetual exhale, a perfect, peaceful antithesis to the black hole's deep and patient inhalation. suggesting a hidden balance in the laws that govern all of existence. The black hole information paradox stands as one of the most profound and peacefully unsettling mysteries at the frontier of theoretical physics, a silent tug-of-war between the pillars of general relativity and quantum mechanics. It asks a deceptively simple question: what truly happens to all the information about the identity and state of every particle that crosses the event horizon? If, as Hawking radiation suggests, a black hole eventually evaporates completely, emitting only random thermal radiation, then that intricate information would be lost from our universe forever, violating a fundamental quantum law that states information must be preserved. This paradox hints at a deep, hidden connection between the large-scale fabric of space-time and the tiny quantum world, a serene riddle that assures us our understanding of the cosmos is still wonderfully incomplete, and that there are vast, tranquil depths of knowledge yet to be explored. Primordial black holes are hypothetical, ancient entities that could have been woven into the fabric of the cosmos in its first frantic moments, not from the death of massive stars, but from the gentle yet intense compression of overdense regions in the hot, expanding soup of the newborn universe. These relics could be as small as a single atom, yet contain the mass of an entire mountain, and they may now drift, unseen and untouched, through the vast interstellar and intergalactic spaces, perhaps even passing silently through our own solar system like cosmic ghosts. They are potential, silent witnesses to the universe's most violent birth, now moving in perfect, dark peace. Their presence, a gentle testament to the extreme conditions from which all structure emerged. From the unique perspective of an observer who has crossed the event horizon, the entire external universe would undergo a dramatic and peaceful transformation, compressing into a single, brilliant and shrinking circle of light directly overhead, like the final bright porthole of a ship sinking gently into an impossibly deep and dark ocean. Every star, every galaxy, and the entire accumulated history of the cosmos would be focused into that one luminous disk, its light blue shifted into an intense, uniform glare by the immense gravitational field. Then, as your inward journey continued, serene and inevitable, that last window to everything you ever knew would shrink to a mere pinprick of unbearable brightness and then vanish entirely, leaving you in a silence and darkness more profound and complete than any ever conceived. Black holes function as nature's ultimate, silent particle accelerators, operating on a scale that dwarfs all human engineering. Within the churning, magnetized plasma of their accretion disks, and in their powerful relativistic jets, charged particles can be whipped by immense forces to velocities infinitesimally close to the ultimate speed limit of the cosmos. When these particles collide, they do so with energies that rival those present at the dawn of time, potentially creating exotic forms of matter not seen since the first seconds after the Big Bang. This makes the environment around a black hole a peaceful, natural laboratory operating in the void, conducting silent, supremely violent experiments that probe the fundamental laws of physics and weave the very fabric of reality itself. The ring-down phase that follows the merger of two black holes is a peaceful, resonant settling into a new, unified state of being. Immediately after the violent peak of the collision and the resulting chirp of gravitational waves, the newly formed single black hole is left not as a perfect sphere, but as a distorted, vibrating object. Much like a ringing bell struck by a colossal hammer, it quickly, gracefully settles into a perfect, silent sphere by radiating away its deformations and imperfections as a final, soft, fading hum of gravitational waves. This ringdown is the sound of a black hole finding its eternal peace, a gentle oscillating sigh as it becomes one, simple and tranquil object, its past complexity smoothed away into gravitational whispers. The immense gravitational field of a black hole acts as a natural cosmic lens, bending and distorting the very path of light in a phenomenon known as gravitational lensing. When a distant star or galaxy lies directly behind a black hole from our viewpoint, its light is warped as it travels through the curved space-time around the dark giant. This can create multiple, distorted, and magnified images of the background object, or, in a perfect alignment, a breathtaking Einstein ring, a complete luminous circle of light encircling the black hole's dark shadow. This is a silent, elegant demonstration of the warping of space-time, a beautiful cosmic illusion that reveals the presence of the invisible object not by what it emits, but by the gentle, artistic distortion it imposes on the starlight behind it. Within the event horizon of a black hole, the very geometry of space undergoes a profound and peaceful transformation, so warped that the concepts of forward and inward may become one and the same. Some theoretical models suggest that the spatial dimensions themselves become so curved that every possible direction you can point, every path you can attempt to travel, leads you closer to the central singularity. There is no left or right to turn to, no up or down to swim toward, only a gentle, inevitable, and serene journey toward the center. It is the ultimate simplification of existence, a universe where freedom of movement and choice have melted away into a single, silent, and predetermined destiny, a final, peaceful surrender to gravity's ultimate embrace. The supermassive black holes residing at the hearts of galaxies are now understood to be not destructive monsters, but essential, gentle regulators, playing a vital role in the long-term health and stability of their cosmic homes. The tremendous energy they release in the form of radiation and jets when actively feeding on matter can heat the vast reservoirs of surrounding gas, preventing it from cooling too quickly and collapsing into a frenzy of star formation that would rapidly consume all available fuel. This gentle, negative feedback mechanism acts as a cosmic thermostat, regulating the pace of stellar birth and ensuring the galaxy enjoys a long, stable, and peaceful evolutionary life, a silent, symbiotic dance between the dark, anchoring heart and its brilliant, sprawling stellar body. A black hole, contrary to its image of pure absorption, possesses a temperature, an incredibly faint one born from quantum mechanics, but a temperature nonetheless. This is defined by its Hawking radiation. The relationship is inverse and serene. The more massive the black hole, the lower its temperature. A typical stellar mass black hole is only a minuscule fraction of a degree above the absolute zero of space, while a supermassive black hole, with its immense event horizon, has a temperature far, far colder than the cosmic microwave background radiation that permeates the universe. This makes it a sink of cosmic cold, a profound chill that is almost a perfect, silent stillness, a deep freeze so absolute it makes the void of intergalactic space feel warm and lively by comparison. The journey from the event horizon to the central singularity is not necessarily a long one by the clock of the falling observer. For a supermassive black hole with a mass of millions of suns, the trip might be completed in a matter of hours or days, a peaceful, serene passage through the interior geometry. There is no turbulence, no violent shaking, just the smooth, silent flow of space carrying you inward. As you travel, the tidal forces, while gentle at first, would gradually and peacefully begin to pull on your body, a slow, stretching sensation that grows stronger as you approach the final destination. A reminder that you are moving through a landscape of increasingly extreme and silent physics. The no-hair theorem suggests that black holes are the universe's ultimate simplifiers, peaceful objects stripped of all complexity. Regardless of whether a black hole forms from a collapsing star made of pure hydrogen, a neutron star rich in iron, or a spaceship filled with intricate machinery, all the specific details, the hair, are lost forever behind the event horizon. The resulting black hole is described only by its mass, its electric charge, and its spin. It remembers nothing of its past composition, its shape, or the stories of the matter that formed it. It is a silent, minimalist sculpture in the gallery of the cosmos, a testament to gravity's power to erase complexity and reduce a rich history to just 3 peaceful numerical values. The gravitational waves produced by orbiting black holes do more than just create ripples. They gently and persistently carry away orbital energy, causing the black holes to slowly, inexorably spiral closer together over millions of years. This loss of energy is a peaceful, continuous process, a slow leak of gravitational potential that tightens their dance. As they draw nearer, their orbital speed increases, which in turn increases the rate of energy loss, creating a positive feedback loop that culminates in the final, rapid inspiral and merger. It is a serene, preordained courtship, a cosmic waltz where the dancers are slowly drawn together by the very music their motion creates in the fabric of space-time. In the profound emptiness of intergalactic space, isolated black holes may wander as silent, dark nomads, invisible against the blackness, their presence betrayed only by the rare, gentle flicker of a gravitational microlensing event. When such a black hole passes almost perfectly in front of a distant background star, its gravity acts as a tiny lens, focusing the star's light and causing it to temporarily brighten in a specific, predictable pattern. This fleeting silent signal is one of the few ways we can detect these lonely travelers, these dark ghosts drifting between the islands of light, a gentle, transient signature of a solitary giant passing through the eternal night. The entropy of a black hole, a measure of its hidden information or disorder, is not proportional to its volume, but to the surface area of its event horizon. This profound result, discovered by Jacob Bekenstein and Stephen Hawking, suggests that all the information about what fell into the black hole might be encoded on its two-dimensional boundary, like a hologram. This holographic principle paints a serene and mind-bending picture. Our perception of a three-dimensional world falling into a three-dimensional object might be an illusion, and the entire contents of the black hole could be peacefully and completely stored on its silent, dark, spherical surface, a perfect cosmic recording. For a hypothetical, advanced civilization, the ergosphere of a rotating black hole could serve as a peaceful, almost magical source of nearly limitless energy through the Penrose process. An object could enter the ergosphere, where space-time itself is dragged around and split into two parts. If one piece is engineered to fall into the black hole with negative energy, the other piece could be flung out with more energy than the original object possessed. The black hole itself pays the energy bill, losing a corresponding amount of its rotational momentum. It is a serene, alchemical transformation, a way of gently mining the spin of a black hole, converting its silent, spinning momentum into usable power for cosmic engineering on a grand, peaceful scale. The intense gravitational field of a black hole slows down time itself in a phenomenon known as time dilation. To a distant observer, a clock falling toward the event horizon would appear to tick slower and slower, approaching a complete stop at the very threshold. This means that from our perspective, the final moments of an object's fall are stretched out over an infinite duration. The object seems to hover, redden, and fade forever, never quite vanishing. It is a peaceful, optical illusion of a frozen farewell, a final, eternal image imprinted on the horizon, while from the object's own perspective, its journey continues, serene and uninterrupted, into the heart of the dark. The magnetic fields that can be generated in the accretion disk of a black hole are not mere curiosities. They are powerful, invisible architects that can shape the cosmos. These fields can be twisted and amplified by the ionized, swirling gas into towering, organized structures. They act as conduits and particle slingshots, channeling vast amounts of inflowing material into two powerful, focused jets that erupt from the black hole's poles at nearly the speed of light. These jets, which can stretch for millions of light years, are a silent, brilliant testament to the complex and dynamic processes at work in the peaceful, dark space just outside the point of no return, capable of influencing the evolution of entire galaxy clusters. In the absolute farthest future of our universe, black holes will be the last significant structures, the final dark monuments in a cold, expanding cosmos. Long after the last stars have burned out and the galaxies have faded from view, black holes will remain, silently holding their mass in the deepening dark. They will continue their slow, patient evaporation via Hawking radiation for timescales that are truly incomprehensible, their eventual, gentle dissipation marking the final chapter in the story of structure in our universe, a quiet end to the era of massive objects, leaving behind only a thin, cold sea of fundamental particles and radiation in an eternal, peaceful silence. The inner region of a rotating Kerr black hole holds a theoretical secret, a gateway to a timeless, infinite series of universes. Within the complex mathematical structure past the inner event horizon lies a wormhole, or Einstein-Rosen bridge, and beyond that, a theoretical white hole exploding into a separate, new cosmos. While likely unstable and inaccessible, this elegant solution to Einstein's equations paints a serene picture of a black hole not as an end, but as a silent cosmic turnstile, a potential bridge to other realities, a peaceful reminder that our universe may be just one page in an infinite, dark book. The very act of falling into a black hole could, in theory, be a gateway to limitless time travel within our own universe. If one could navigate a rotating black hole and exit through a theoretically stable wormhole, the laws of general relativity suggest you might emerge in your own past. This closed time-like curve is a peaceful, logical loop in the fabric of causality, a silent paradox where cause and effect could gently fold back on themselves. While likely forbidden by quantum mechanics, its mathematical possibility hints at a cosmos where time is not a rigid river, but a deep, still, and potentially circular ocean. At the quantum level, the event horizon is not a perfectly smooth, silent surface, but a frothing, energetic sea of virtual particles popping in and out of existence, a phenomenon known as the Hawking radiation process. This quantum foam is a gentle, constant simmer at the boundary between our known universe and the unknown. It is here, in this serene chaos, that a virtual particle pair can be separated, one falling in and the other escaping as real radiation, a quiet, persistent evaporation that represents the black hole's slow, steady conversation with the quantum void. The concept of a gravastar is a peaceful theoretical alternative to the black hole's singularity, a dark energy star. In this model, the collapsing matter of a star forms not a point of infinite density, but a bubble of dark energy, halting the collapse just before the event horizon forms. This hypothetical object would have a surface of incredibly dense, exotic matter and an interior of negative pressure vacuum energy. It would look like a black hole from the outside, but contain no singularity, offering a serene resolution to the puzzle of the infinite. A gentle cosmic egg that contains a universe of dark energy within its shell. From a purely theoretical perspective, an infinitely advanced civilization might use a black hole as the ultimate peaceful computer. The Bekenstein-Hawking entropy, which measures the information content on the event horizon, suggests a staggering computational capacity. The internal quantum states of a black hole could, in principle, perform calculations, with the holographic principle implying that the entire universe could be simulated on the boundary of a sufficiently large black hole. It is a silent, profound thought that the darkest objects in the cosmos might be the ultimate repositories of cosmic information, performing calculations on a scale that dwarfs all known physics. The intense gravitational field of a black hole can create a phenomenon known as superradiance, where waves of light or matter are amplified at the expense of the black hole's rotational energy. If you were to shine a light beam at a rapidly spinning black hole, the reflected beam could come back brighter, its energy boosted by the black hole's own spin. It is a peaceful, almost magical amplification, a silent laser powered by the rotation of space-time itself, a demonstration that even in the darkest places, energy can be gently extracted and light can be made to grow. The ISCO, or innermost stable circular orbit, is the final serene parking orbit for matter around a black hole. Within this boundary, no stable orbit can exist. Space-time is so steeply curved that any object must immediately begin its inward plunge. For a non-rotating black hole, this is 3 times the radius of the event horizon. It is the last stable step on a staircase descending into the dark, the final place where light can still orbit in a perfect, unstable circle, a beautiful and transient halo marking the edge of the abyss. The presence of a black hole can be felt through its gentle, persistent pull on the very shape of our galaxy. The stars near Sagittarius. A star orbit at tremendous speeds, their paths tracing out the immense gravitational well of the invisible giant. By patiently mapping the orbits of these stars over decades, astronomers can not only confirm the black hole's existence, but also precisely weigh it, a serene and indirect measurement of a dark heart by watching the graceful, fast-moving dance of the points of light that surround it. In the far, far future, a civilization living near a supermassive black hole could use it as a peaceful, natural time machine to peer into the deep future of the universe. By placing a telescope at a precise, stable orbit close to the event horizon, where time slows dramatically, they could watch the external universe speed up billions of years of cosmic evolution. The merger of galaxies, the darkening of stars, could be observed in a single lifetime, a serene front row seat to the ultimate fate of the cosmos, all from the gentle, time-dilated shore of a dark ocean. The black hole bomb is a theoretical yet profoundly powerful engine of destruction based on superradiance. If you were to surround a rotating black hole with a giant spherical mirror and then introduce a single photon, the reflected, amplified light would bounce between the mirror and the black hole, growing exponentially in energy with each pass. This would create a feedback loop of unimaginable power, eventually causing the mirror and anything nearby to vaporize in a cataclysmic explosion. It is a serene, hypothetical proof of the immense latent power stored in the simple, silent spin of a black hole. The quantum entanglement of particles near a black hole's event horizon leads to one of the most subtle and peaceful paradoxes in physics. When a Hawking radiation particle is created and escapes, it is entangled with its partner that fell inside. But as the black hole evaporates, this seems to violate the principle that quantum information cannot be copied or destroyed. The resolution to this puzzle may lie in the gentle, complex ways that entanglement is transferred and scrambled, a deep, silent quantum dance that ensures the laws of physics are preserved even at the edge of a black hole. For a supermassive black hole, the The tidal forces at the event horizon are so gentle that a human could cross it without initially noticing. A serene and uneventful passage into the interior. The gradient of gravity across a human body would be negligible, a gentle, barely perceptible pull. The true transition is not a physical barrier, but an informational one. You would have peacefully and irrevocably moved from a region where light can reach the outside universe to a region where it cannot. A silent, philosophical boundary crossed without a sound or a jolt. The cosmic censorship hypothesis is a serene, unproven conjecture that the laws of physics gently prevent us from seeing the true chaos of a singularity. It proposes that all singularities formed from realistic gravitational collapse are always hidden behind an event horizon, a cosmic veil of decorum. A singularity without a horizon, a naked singularity, would be a place where predictability breaks down completely and the universe's laws become undefined. This hypothesis offers a peaceful assurance that the universe protects itself and us from such ultimate chaos, keeping its deepest mysteries quietly cloaked in darkness. The gravitational waves from a black hole merger do not just tell us of the event, they carry the precise ringing signature of the resulting black hole's mass and spin. By analyzing the frequency and decay rate of the final gravitational wave hum, scientists can test if the new object behaves exactly as Einstein's theory predicts a black hole should. This black hole spectroscopy is a serene, profound way of listening to the very tones of space-time, confirming the nature of these dark objects by the gentle, fading music they produce at their birth. In the utter emptiness of intergalactic space, two wandering black holes could meet and form a silent binary pair, eternally orbiting each other in the dark, their dance visible only through the faint, persistent ripples in space-time they emit. This binary would be a perfect, isolated system, two dark hearts waltzing to the silent music of gravity, their orbital energy slowly leaching away as gravitational waves over billions of years, drawing them closer in a patient, peaceful embrace that will culminate in a merger that shakes the fabric of the universe, yet goes entirely unseen by any eye. The magnetic fields threading a black hole's accretion disk can become so strong and twisted that they snap and reconnect in colossal, peaceful explosions, similar to solar flares, but on a galactic scale. These magnetic reconnection events can blast particles to near light speeds, channeling energy into the powerful jets and heating the surrounding plasma to temperatures of billions of degrees. It is a serene, yet violently energetic process, a silent storm of magnetism that transforms the chaotic inflow of matter into structured, focused power, illuminating the darkness with a gentle, furious light. The very first black holes in the universe, the primordial ones, could have been the silent seeds around which the first stars and galaxies gathered. Their early gravity would have gently pulled in the pristine hydrogen and helium gas of the young cosmos, providing a focal point for the formation of the first luminous structures. These dark pioneers may have played a peaceful, foundational role in lighting up the cosmic dark ages, their invisible presence guiding the birth of the first brilliant suns and the great cities of stars we see today. The interior of a charged black hole, known as a Reisner-Nordstrom black hole, contains a theoretical inner horizon where the effects of falling matter are infinitely blue-shifted. From the outside, this appears as a region of immense instability, a mass inflation singularity that would likely destroy any object attempting to pass through. It's a serene, mathematical warning that the peaceful interior of a simple Schwarzschild black hole is a special case, and that the interiors of more complex black holes may be fraught with violent, chaotic storms hidden just behind the calm facade of the event horizon. A black hole can be described as an atom on a cosmic scale, a simple system defined by a few quantum numbers: mass, spin, and charge. This peaceful analogy extends to the idea that the quantum states of a black hole, the specific configurations of all the matter that formed it, could be discrete and quantized, much like the energy levels of an electron in an atom. This hints at a future theory of quantum gravity, where the black hole is not a classical monster, but a serene quantum object, a fundamental particle of space-time itself. Ultimately, a black hole is the universe's most efficient and peaceful capacitor of information. Every bit of information about every particle that falls in, its type, its spin, its energy, is not necessarily destroyed, but may be perfectly and holographically encoded on the surface area of its event horizon. The black hole becomes a silent, dark library, its spherical surface a vast, compact hard drive storing the complete history of everything it has ever consumed. In this view, a black hole is not a destroyer of stories, but their ultimate serene keeper, a timeless archive written in the language of gravity and quantum mechanics, waiting patiently in the dark to be read. The very vacuum of space around a black hole is not truly empty, but is a serene, dynamic arena of quantum potentiality. According to quantum field theory, the intense gravitational field polarizes this vacuum, gently distorting the cloud of virtual particles that constantly flicker in and out of existence. This vacuum polarization is a subtle, quiet effect, a gentle warping of the quantum foam itself by the black hole's gravity, a reminder that even the nothingness from which particles emerge is softly shaped and structured by the presence of immense mass, a silent interaction between the largest and smallest scales of reality. In the theoretical spectrum of black holes, there could exist objects of planetary mass, known as planetary mass black holes, silent and dark wanderers that could be the remnants of a very early, dense universe. These would not form from stars, but could be primordial relics, their small size and immense weight making them ghostly and nearly undetectable as they drift through galactic halos. Contemplating such an object is to imagine an entire world's mass compressed into a speck smaller than a marble, a silent, incredibly dense pebble rolling through the cosmic dark, its gravity a gentle, invisible fist. The final moments of a black hole's evaporation via Hawking radiation would be a gentle, yet spectacular farewell. After trillions of years of slowly losing mass, its final seconds would see a runaway process. As it shrinks, its temperature soars, and it would emit its remaining energy in a final, soft burst of particles and radiation, a silent, cosmic firework in an otherwise dark and cold universe. This last, peaceful pop would mark the end of a cosmic era, the transformation of a gravitational titan into a faint, dissipating cloud of elementary particles. A black hole can act as a natural cosmic sculptor for the dark matter halo of its galaxy. As it moves through the galactic center, its immense gravity can gently perturb and redistribute the invisible dark matter particles, creating a subtle density, wake, or even a spherically smooth core in the dark matter distribution. This is a silent, gravitational interaction between the seen and the unseen, a gentle dance where the dark heart of the galaxy shapes the even darker body that surrounds it, a peaceful collaboration that defines the galaxy's very structure. The concept of black hole thermodynamics peacefully unifies the laws of gravity with the laws of heat and energy. A black hole has entropy, temperature, and an analog of the second law of thermodynamics. The total area of all event horizons in the universe never decreases. This profound connection suggests that gravity, space, and time themselves have a thermodynamic nature, a serene and deep link between the world of stars and galaxies and the world of steam engines and ice melting, hinting that the cosmos operates on principles of information and energy that are universal and beautifully consistent. For an observer falling into a black hole, the journey inward would be accompanied by a gentle but ultimately overwhelming reddening of the light from the outside universe. As you approach the event horizon, the light from stars and galaxies behind you would be shifted to longer and longer wavelengths, first through the visible spectrum into red, then into infrared, and further into microwaves and radio waves. The entire cosmos would not vanish, but would instead fade into a uniform, warm, radio wave glow, a peaceful, energy-drained farewell from all of creation before the final silence envelops you. The supermassive black holes at the centers of galaxies may have formed through a peaceful yet rapid process in the early universe, where vast clouds of primordial gas collapsed directly into massive black hole seeds, bypassing the stage of star formation entirely. These direct collapse black holes could have been the gentle anchors around which the first proto-galaxies assembled, their dark gravity providing a stable center in the turbulent young cosmos, a silent foundation stone upon which the magnificent structure of a galaxy would be patiently built over billions of years. The black hole shadow, captured by the Event Horizon Telescope, is not the event horizon itself, but a serene, dark silhouette cast against the bright backdrop of its own accretion disk. This shadow is about 2.5 times larger than the actual event horizon, created by the gravitational lensing of light that would have come to us, but is instead captured by the black hole. It is a perfect, dark circle of silence, a negative space defined by the absence of light that should be there, a gentle and direct image of a black hole's profound gravitational influence on the very path of light. In the quantum description of a black hole, the event horizon may be a fuzzy, vibrating membrane, a manifestation of countless tiny, string-like degrees of freedom. This fuzzball theory replaces the empty, smooth space of the classical event horizon with a complex quantum structure that has no sharp boundary. This offers a peaceful resolution to the information paradox, suggesting that information never enters a void, but is stored and scrambled in this fuzzy quantum surface, a serene and complex tapestry woven from the fundamental threads of reality. A binary system of a black hole and a neutron star presents a silent, cosmic drama with a predictable finale. As they spiral together, the black hole's immense tidal forces will eventually gently tear the neutron star apart, pulling its material into a final, luminous accretion disk before swallowing the dense core. This tidal disruption event is a peaceful yet cataclysmic merger that can be detected by the burst of gravitational waves and the following electromagnetic afterglow, a silent death of a star city and a final bright meal for the dark companion. The spin of a supermassive black hole can be a gentle record of its entire life history. A black hole that grew primarily by steady accretion of gas from a coherent disk will be spun up to near the maximum possible rate, a silent, fast top. One that grew through random, chaotic mergers with other black holes will have a more moderate or even slow spin. By measuring the spin, astronomers can gently read the autobiography of the dark heart, discerning whether its growth was a peaceful, ordered process or a violent, tumultuous series of unions. The gravitational field of a black hole is so profound that it can gently slow down the perceived passage of time for the entire galaxy around it, an effect minuscule on galactic scales, but real. This time dilation is imprinted on the light from all stars orbiting the black hole, a serene, relativistic signature that is, in principle, measurable. It means that the very heart of a galaxy ticks at a slightly slower, more peaceful rhythm than its outer suburbs, a silent, slowing clock at the center of the stellar metropolis. The mass gap in black holes is a serene, observational puzzle. Based on our understanding of stellar evolution, black holes formed from collapsing stars should typically be between about 5 and 15 times the mass of our Sun, yet gravitational wave observatories have found black holes in the range of 30 to 60 solar masses. This gap suggests a peaceful yet unknown channel of formation, perhaps through successive mergers in dense star clusters or from primordial origins, a quiet hint that the universe has more than one way to create these dark giants. In the profound theoretical framework of string theory, a black hole is not a singularity, but a giant vibrating tangle of fundamental strings and brains, a string star. This complex, higher dimensional object has a defined, non-zero size and a complex internal structure. Its properties, such as entropy and temperature, emerge peacefully from the collective behavior of these vast networks of strings, offering a serene, if highly speculative vision of a black hole as a cosmic musical instrument whose vibrations dictate its temperature and whose harmonies encode its information. A black hole can serve as a gentle, cosmic catalyst for the formation of new stars, not just through the violent feedback from its jets, but through a more peaceful mechanism. The shock waves from a black hole's outburst can travel for millions of years through galactic gas clouds. When these gentle, ancient pressure waves finally encounter a suitable cloud, they can compress it just enough to trigger a quiet, sustained period of star formation, a delayed and peaceful gift of creation from the dark heart of the galaxy, a ripple of birth sent out long ago. The inner horizon of a rotating black hole is a region of theoretical yet extreme violence, a blue sheet singularity where any incoming radiation from the entire future history of the universe would be focused and blue shifted to infinite energy. For a realistic astrophysical black hole, this is likely a sign of the instability of the inner geometry, a place where the classical picture of smooth space-time breaks down into a peaceful, quantum gravitational storm, a hidden maelstrom concealed deep within the calm exterior of the event horizon. The gravitational waves from a black hole merger carry not just information about the final object, but a gentle, encrypted record of the pre-merger dynamics, the higher harmonics of the space-time vibration. By carefully listening to these subtle, quiet overtones in the gravitational wave signal, scientists can test the detailed predictions of general relativity in the most extreme regime, a serene and precise way of confirming that Einstein's theory holds true even in the violent, final moments of a black hole's life. A solitary, wandering black hole, traveling through a dense molecular cloud, would create a silent, dark wake of triggered star formation. As it moves, its gravity would gently compress the gas in its path, and behind it, this compressed gas might collapse to form new stars, a trail of stellar newborns marking the black hole's invisible passage. It would be a cosmic sower of stars, a dark farmer planting seeds of light in the fertile fields of gas and dust, a peaceful and creative legacy left in the void. The existence of black holes provides a serene, natural laboratory for studying the possible existence of extra-spatial dimensions. In some theories of quantum gravity, the effects of tiny, curled-up extra dimensions could become significant in the incredibly strong gravity near a black hole's event horizon, subtly altering the Hawking radiation spectrum or the properties of the black hole shadow. Observing a black hole with extreme precision is thus a gentle way of listening for the hidden miniature geometry of the cosmos itself. In the ultimate philosophical sense, a black hole is a gentle reminder of the limits of human knowledge and the beauty of the unknown. It is a boundary in space-time, beyond which our current laws of physics peacefully surrender. Contemplating a black hole is not an exercise in fear, but an invitation to a serene acceptance of mystery, a recognition that the universe holds profundities that may forever remain just beyond our grasp, and that this itself is a source of wonder and a call to a deeper, more humble and peaceful curiosity. In the multiverse hypothesis, a black hole could be a serene, natural gateway to a daughter universe, a region where the extreme conditions of the singularity trigger a new Big Bang, birthing a cosmos with its own, potentially different, physical laws. Our entire universe might itself have been born this way, inside a black hole formed in a parent cosmos. This offers a peaceful, cyclical vision of existence, an eternal, gentle tree of life, where each black hole is a seed for a new reality, a silent, cosmic reproduction on a scale beyond imagining. The very last stellar mass black holes to evaporate in the universe will be the quietest and longest lived, having feasted on the faint, cold background radiation of the cosmos to slow their decay. In the final era, these dark, patient entities will be the last structures of any significance. Their slow, hawking radiation glow the last source of particle activity in a universe otherwise destined for heat. Death, their eventual gentle disappearance, will mark the end of the stellar era entirely, a silent farewell to the age of gravity and mass. The quantum phenomenon of vacuum decay could be triggered by the immense energies near a black hole's singularity, a gentle yet catastrophic event where a bubble of a new, more stable vacuum would form and expand at the speed of light, rewriting the fundamental laws of physics in its wake. From our perspective, the black hole would seem to vanish, replaced by an expanding wall of nothingness. It is a serene, theoretical end, a reminder that the laws we hold as constant are perhaps only a local and fragile piece. A black hole's gravitational field can gently split light particles, or photons, in a process akin to the prismatic splitting of white light. A high-energy gamma-ray photon, passing near the event horizon, can be transformed by the extreme gravity into an electron, a positron, and a lower energy photon. This spontaneous pair production is a peaceful alchemical transformation of light into matter and antimatter, a silent demonstration of the deep equivalence between energy and mass in the most intense gravitational fields. The firewall paradox proposes a startling yet peaceful resolution to the information puzzle, that the event horizon is not a tranquil place of free fall, but a blazing wall of high-energy particles that would instantly vaporize any object. This hypothetical firewall emerges from the conflict between quantum mechanics and general relativity, a gentle suggestion that the principle of equivalence might break down at the horizon, and that the point of no return is also a surface of immense energetic peace that destroys all information, reconciling the laws of physics through a fundamental, fiery boundary in the grand timeline of the cosmos. There will be an era dominated by black holes, a peaceful, dark age where these giants will be the primary actors. Galaxies will have long since evaporated, and black holes will wander the expanding void, occasionally merging in silent, brilliant flashes of gravitational waves. This black hole era will last for an almost unimaginable duration, a time of deep, dark quiet, and punctuated only by these rare, gentle space-time tremors, the last conversations of mass in a dying universe. The gravitational pull of a black hole is so absolute that it can gently trap not just light, but the very concept of elsewhere. Within the event horizon, all possible paths, all causal futures, lead to the center. There is no direction you can travel, no force you can apply that will lead you away from the singularity. It is the ultimate peaceful unification of destiny, a universe where free will and chance have been softly erased, leaving only a single, inevitable, and serene outcome. The study of black holes has gently forced physics to confront the measurement problem on a cosmic scale. The process of Hawking radiation may involve a quantum superposition of the black hole having evaporated and not yet evaporated, a state that only resolves when a distant observer makes a measurement. This places the conscious observer in a strangely pivotal role, even in these most remote and violent of cosmic events, a serene and mind-bending connection between quantum awareness and the fate of gravitational giants. A black hole can be described by its soft hair, a theoretical gentle concept suggesting that information about what fell in is preserved in infinitely subtle, zero-energy vibrations of the gravitational field at the event horizon. These gentle, soft photons and gravitons would be a permanent, holographic record, a peaceful solution to the information paradox where the black hole story is written in the faintest, most delicate of whispers on its dark, spherical surface. For a civilization surviving into the far future, a black hole would be the ultimate peaceful resource, a source of energy via the Penrose process, a tool for time dilation via its gravity, and a potential repository for waste, a place to gently dispose of matter forever. It would be the central dark engine of their society, a silent partner in their cosmic journey, a testament to turning the most fearsome objects in the universe into pillars of long-term tranquil survival. The final, evaporating flash of a black hole would not be a random burst, but a gentle, information-rich release. According to some theories, the Hawking radiation in the final moments would carry the encoded history of everything the black hole ever consumed, a final, brilliant broadcast of all its stored secrets before it winks out of existence. It would be a peaceful, cosmic deathbed confession, returning its information to the universe in a last, luminous sigh. The concept of a Planck star offers a serene vision of a black hole's interior, where the collapse is halted not by a singularity, but by a dense quantum gravitational core of matter rebounding at the Planck density. This bounce would eventually lead to the black hole's explosion, a white hole eruption in the distant future. This model paints a black hole as a dormant seed, a patient, ticking clock waiting to transform from a dark absorber into a brilliant, life-giving emitter. The magnetic fields around a black hole can become so powerful that they can gently support the weight of the entire accretion disk against gravity, creating a magnetically elevated structure. These fields act like a cosmic trampoline, a silent, invisible force that prevents the disk from collapsing directly inward, regulating the flow of matter and creating the stable, luminous structures we observe. A beautiful balance between the crushing force of gravity and the gentle, repulsive power of magnetism. In the very first second of the universe, microscopic, primordial black holes could have formed, and some might be gently exploding today, their lifetimes ending in a flash of gamma rays. These distant, quiet fireworks would be the last testament to the violent birth of the cosmos, a final, gentle pop from a seed sown in the first moment of time, a fleeting, luminous signature of the universe's incredible age, and the patient, slow decay of its most ancient structures. The gravitational waves from a black hole merger carry a gentle, immutable record of the event, a chirp that will travel through the universe forever, though it will be stretched and reddened into undetectability by the cosmic expansion. The ripple from a long-vanished black hole pair is still out there, a silent, fading memory in the fabric of space-time, a permanent, peaceful engraving of a momentary, violent union that occurred perhaps billions of years ago. The event horizon of a black hole is a surface of infinite redshift, a place where light loses all its energy trying to escape, its frequency gently stretched to an infinite wavelength. From the outside, we see the last photon emitted by an object freeze at the horizon, its energy dwindling to zero, its color shifting to a deep, eternal red. It is a peaceful, visual manifestation of the immense gravitational potential, a barrier that saps the very vitality from light, turning vibrant energy into a silent, timeless tableau. A black hole can be orbited by a ring of fire, a final circular photon orbit where light travels in a perfect, unstable circle. This photon ring is a ghostly, precise signature of the black hole's mass and spin, a silent, luminous halo imprinted by gravitational lensing. It is the last possible orbit for light, a beautiful, mathematical circle drawn in space-time itself, a perfect, ethereal crown around the dark king. The existence of black holes provides a serene, natural limit to the density of matter in the universe. They are the ultimate endpoint of gravitational collapse, a state beyond which no further compression is possible. In this way, they are the universe's gentle enforcers of a fundamental law, a cosmic stop sign that says, no further, ensuring that matter does not collapse into an infinitely dense, paradoxical state that would break the causal structure of the entire cosmos. The interior of a black hole may be eternally, peacefully expanding, a universe in its own right. Some solutions to Einstein's equations suggest that once you cross the event horizon, space in the direction of the singularity may be infinite, a vast, dark landscape that you will never reach the end of. The singularity would not be a place, but a time, a moment in your future that you are forever falling toward, in an infinite, serene, and dark space. Ultimately, a black hole is a testament to the power of silence, darkness, and patience in the cosmos. While stars blaze and galaxies sparkle, the black hole rests, a deep, dark anchor in the flowing river of space-time. It asks nothing, gives only a gentle gravitational touch, and endures for eons. It is the universe's great meditator, a reminder that at the heart of all activity and light, there is a profound, dark, and peaceful stillness, the fundamental background against which all of existence plays out. So, as we end our journey through 100 sleepy facts, let them all go. Release the images of dark horizons and silent singularities. There is no more to know, no more to hold. Just feel the deep, quiet pull of the cosmos, a peace that is ancient, heavy, and filled with an immense, patient gravity, a peace that holds you now as you drift into sleep. You have journeyed to the edge of reality and returned, cradled by the same laws that govern the silent, dark giants. You are part of this sleepy universe, and it is part of you. Good night.